This is a topic you are probably very familiar with. You know that most of the time, if you have something that you want to dissolve in water or a beverage, that if you heat it up, more will dissolve and it dissolves, thoroughly. And the best example is tea. If you are in a place that makes like huge amounts of tea and they put them in those brown big storage containers for people to get. If you put it in and you add a whole lot of sugar while it's hot, then when you add it, immediately dissolves up and you don't see the cube anymore. You can put more in and dissolve up and you can't see the cube anymore. And then you also probably know, especially if you know someone who is not a sweet tea drinker, who likes iced tea instead. So here we've got some iced tea in here. And then if we go to put in some cubes of sugar, in this way, when you put it in, like it just won't take very much. Some will dissolve, but just not that much. So in general, as you increase the temperature, the solubility, that's how well it dissolves, of the salt increases. Now, I want to mention an important exception, and that has to do actually with NaCl. That's our regular salt. That's the kind of salt you're going to find in the ocean. There's other salts that we generically call salt, like any positive, negative charge we call salt. So that's kind of confusing in chemistry. So even like that is a salt because it has positives and negatives. Whereas colloquially, when we're seasoning our foods and everything, we're saying salts, but what we really mean is sodium chloride. So the ocean has a lot of sodium chloride and it has other things in it too. But if we're looking at sodium chloride, it's really interesting because this is one of the few salts that is not strongly affected by temperature. A little tiny bit more will go in when the temperature changes, but not a lot. And you'll have to think of the advantage of that to the oceans and all the sea life in the oceans, because if you had salt and, as the temperature changes, if you go to the beach in February and then you go to the beach in August, the temperature of that water is completely different by several degrees. And so you can imagine that like if salt became more soluble with a higher temperature, that could mess up our sea life. So it's actually really good. So that's one of the few exceptions. So every once in a while you'll get a baseline. And there are a few salts that prefer and will increase solubility when they get cold. But for the most part, like the majority of salts, you add solid at a good temperature and it increases. And we've got a lovely little graph. I always love these graphs that have lines going all over the place. But what this is as temperature increases, so increasing to the right, so this is going up. That means up in solubility because this is low solubility and this is high solubility. So as you increase the temperature, sugar increases, NaNO3, KNO3, KBr, KCl goes up some, but you'll notice right here our sodium chloride and this guy, cesium sulfate, those ones don't change a lot. And then our sodium bromide only just barely goes up some. But for the most part, most of them will increase. But if you really had to answer this question, then you would actually need a chart like this or data to let you be able to say, oh, well, it actually does increase. And I can see that on the chart, or it decreases.